All right, let's dive right in. Today, we're tackling deep learning, the incredible engine that's powering the most advanced AI systems on the planet. So, here's our game plan. We'll kick things off with the deep learning revolution. Then we'll zoom in to look inside the artificial neuron. After that, we'll explore the main architectures powering AI today, figure out how these digital brains are trained, see where they're popping up in our world, and finally, gaze into the future at the next frontier. Okay, first up, the deep learning revolution. To really get a handle on where AI is headed, we first need to understand what makes this whole approach so different and, frankly, so powerful. So, what in the world is deep learning? Well, at its heart, it's a kind of machine learning that uses these things called artificial neural networks. And the deep part? That's not just for show. It literally means these networks have lots and lots of layers. And that depth is the secret sauce. It's what lets them learn incredibly complex patterns, building up ideas layer by layer, almost like starting with pixels and ending up with the concept of a cat. And this right here is the key difference, the big shift. With older machine learning methods, you'd need a human expert to painstakingly tell the machine what features to look for in the data. With deep learning, the network figures it out all by itself. It automatically learns what's important, what signals matter. And for really complex problems with mountains of data, that's an absolute game changer. Okay, so to really understand how these massive networks operate, we've got to zoom way, way in. We're going from the 30,000-foot view of the architecture down to the single fundamental building block of it all. Which, of course, begs the question, why do we even call them neural networks? What's the connection to, our actual brains? Well, it all boils down to this little guy, the artificial neuron. It's actually a pretty simple concept, inspired by the neurons firing in our heads. It just takes in some signals, does a little bit of math on them, and then passes a new signal along to other neurons. That's it. And the incredible thing is, when you layer thousands or even millions of these simple units together, you get mind-blowing complexity. And its job is surprisingly simple, really. It's just a three-step process. First, it gets a bunch of inputs. Each one has a weight, which is just a way of saying how important that particular signal is. Step 2, it adds up all those weighted inputs and runs them through something called an activation function. And finally, step 3, it shoots that result out to the next layer of neurons. That's the whole process, just repeated over and over and over again. Alright, so we've got our basic Lego brick, the neuron. Now let's see what happens when we start building with them. We're talking about the incredible structures, the architectures that these neurons form to solve some seriously tough problems. And here's the key thing to remember. Deep learning isn't just one thing. It's more like a toolkit. You've got specialized tools for different jobs. The big three, the heavy hitters you'll hear about all the time, are CNNs for anything visual, RNNs for stuff that happens in a sequence, and transformers, which are the rock stars of language. Let's start with CNNs. The easiest way to think about them is as the eyes of an AI. They are absolute masters at processing images. They have these little filters that scan across a picture, and in the first few layers, they learn to spot really basic stuff, like edges, corners, and colors. But as you go deeper, they start piecing those simple things together to recognize complex objects, like a cat, a car, or even a human face. Then you've got RNNs, which you can think of as the memory of AI. Their whole deal is handling data that comes in a sequence, where the order is everything. Think about language, or stock prices. They have this neat trick, a sort of feedback loop, that lets them remember what they just saw. This gives them context, which is why they're so good at things like speech recognition or predicting what's coming next. And that brings us to the real superstar of the last few years, transformers. I mean, these things have completely changed the game. They are the undisputed masters of language. Their secret weapon is something called attention, which lets them figure out which words in a sentence are the most important for understanding the context, even if they're super far apart. You've heard of models like GPT, right? Well, this is the magic that makes them work. Okay, so we have these incredibly powerful blueprints for AI brains. But how do they actually learn anything? How does a network go from being just a random jumble of connections to something that can identify a cat or write a poem? How do we train this digital brain? I absolutely love this analogy because it just clicks. It takes a really complex bit of math and makes it feel simple. Imagine you're stuck on a huge mountain. It's completely foggy and you need to get to the valley below. What would you do? You'd probably just look at your feet and take a step in whatever direction is the steepest downhill, right? Well, that's exactly how we train a neural network. That strategy is called gradient descent. The lowest point in that foggy valley? That's our goal. It represents the point where the model is making the fewest mistakes. So the process is simple. The model makes a guess, checks how wrong it was, and then it tweaks all its internal knobs just a tiny bit to be slightly less wrong. It takes a small step downhill. Then it does it again and again, millions, maybe even billions of times until it finds the bottom. Now, as you can imagine, just taking tiny steps can take forever. So smart folks came up with better ways to get down the hill, smarter optimizers. Things like momentum help the algorithm kind of roll over small bumps instead of getting stuck. But the real all-star is Adam. It's like an expert hiker that knows when to take big strides on flat ground and when to take small, careful steps on steep slopes. It's so good, it's pretty much the go-to standard for training almost any deep learning model today. Alright, enough theory. We've talked neurons, architectures, and training. Now let's get to the fun part. Where is this stuff actually showing up in our world? What is it doing? The honest truth? It's everywhere. You might not even realize it. When a doctor uses AI to analyze an X-ray, that's deep learning. The systems that let a self-driving car see the world, deep learning. That voice assistant on your phone, that app that translates signs in real time, you guessed it. It's even in your entertainment, from the algorithm that knows exactly what movie you want to watch next, to AIs that are generating incredible, mind-bending art. And that brings us to our last big topic. What's next? We've seen just how powerful deep learning is, which means we have a huge responsibility to think about the future. I mean, this is the multi-trillion-dollar question, isn't it? When you create something with this much power, this much ability to learn and even create, where do you go from here? What should we be focused on? And it creates what's being called the AI dilemma. It's this constant balancing act. On one side, you have this relentless push for innovation to build bigger, better, smarter models. But on the other side, you have this absolutely critical need for responsibility. We have to make sure these systems are fair, that we understand how they work, and that they're accountable. Figuring out how to balance those two things, that's probably one of the biggest challenges we face right now. And if you look at where the research is headed, a lot of it is focused on exactly that. You've got transfer learning, which is amazing because it lets people build powerful AI without needing a Google-sized dataset. Then there are generative models, which are just exploding with creativity. And maybe most importantly, there's this huge push for explainable AI, or XAI. The whole goal there is to crack open these black boxes so we can actually understand why an AI made the decision it did. That's a huge step towards building trust. So, there you have it. A whirlwind tour of deep learning, all the way from a single artificial neuron to some of the biggest questions we're facing as a society. It kind of leaves you with one final big thought to chew on, doesn't it? As we get better and better at building machines that learn, what in the end will they teach us about ourselves? Thanks for joining me.